If you didn't start your physical chemistry revision, this video is absolutely for you, because in this video we are going to discuss all those chapters in physical chemistry, and after this video you can go to your worksheet and start solving the problems or start solving the test series. Okay, so that much important this video is. Okay, so I have marked the chapter wise in the timestamp. You can skip those chapters, or whatever the chapter you like, you can check it through. But this video is super important. Okay, the analysis of physical chemistry is that in January attempt, they were asking more of a lengthy question, numerical type of questions from mole concept, atomic structure, whatever the chapter you take, either a statement based question, which is from the core concept, or else they were asking the lengthy numerical problems. So what I suggest you to do is solve each and every problem till the end without using calculator and maintain your time management. Okay, so which will help you to solve the questions in your examination. And also don't write the full mark test for 3 hours. Please don't write it for 3 hours. At least make it 2.5 hours or 2.15 hours. Okay, so that will be very helpful for your examination. So let's get started with the first chapter, mole concept. That is a very simple but very essential chapter to solve the other numerical problems from other chapters, right? Relative atomic mass concept we know, which is from the 1/12 of carbon 12 isotope, and mole and Avogadro's constant. 1 mole is equal to 6.022 into 10 to the power 23, not minus, plus 23. That much big the mole is. Mole is just a number. Okay, it's an it doesn't have any unit, and at STP the molar volume would be 1 mole is equal to, for gases, 1 mole which is equal to 22.4 liters. That applies only for ideal gases. Okay, because we took it from ideal gas equation. Then at STP condition, that's very important. Then molecular and empirical formula. This type of question they were asking again and again by giving the percentage composition. Then the next one is limiting reagent type of question. What is limiting reagent? Which get consumed first, which is responsible to stop the reaction, right? So how you can easily find out the limiting reagent is divide the moles by the stoichiometric coefficient. Balance the equation, get the stoichiometric coefficient, and divide the moles, given moles, by this coefficient. Okay, which one is getting the minimum value, that is your limiting reagent. Another one will excess. Okay, that is a simple step you can follow. And average atomic mass, the sum of abundance into atomic mass divided by the total abundance. Okay, if they have given in percentage, then 100. If they are given in the ratio, then add all those ratio for the denominator. Okay, then there is a slight difference between this average atomic mass and the mean molar mass, where we have number of molar masses we have in mean molar mass of the gaseous mixture. In the first one, I have the abundance, total abundance. Okay, so don't use the same formula. It's almost same too. Then relation between molarity and density. Here you see the solution with molarity m, density rho, and a molar mass m0 I just took, where it gives this relation m is equal to, molarity is equal to m by density minus m into molar mass divided by 1000. Okay, for the dilute solution, for the very dilute solution, what you can take is molarity that is less than 10. Okay, in that case, you can take this equation to get the answer very quickly. And also, don't ever try to forget the density conversion. Okay, many students are doing that mistake. Sometimes the density will be given in different units, gram per ml or kilogram per liter. So please make sure that you are converting it. Okay, and also some common traps or the exceptional cases over here is peroxide and superoxide calculation of atomic state, and then metal hydrides, where the oxidation state of the hydrogen is not +1, it's -1, and OF2, where oxidation state of oxygen is +2. Right? For the non-ideal gas, the molar volume that is not equal to 22.4 liter at STP, it differs. Okay, and equal volumes of gases contain equal moles. that statement of Avogadro will become false if temperature pressure are differing, because he said the condition is under similar conditions. Okay, but here if they didn't provide that statement, then this statement will also get wrong. And the empirical formula mass can equal to molecular formula mass when n is equal to 1 in some cases. Okay, when n is equal to 1, and the molecularity depend on the final solution and not the solvent volume. Solution volume, not the solvent volume. And POAC works only when the atom is conserved. It's not for nuclear reactions. These are some statement-based traps for assess and reason type or statement-based questions. And also in dilution, whenever you are using this formula, the volumes must be in the same units. Please make sure that. And these kind of disproportionation reaction, please do find out the oxidation state changes, because the products, both the products will have different oxidation state, right? Because this is a disproportionation reaction. And comproportionation reaction, again the reactant oxidation state you have to make sure. And whenever you are balancing the equation, OH minus in the acidic medium, which become incorrect, and ion electron method, balance the charge after balancing the atoms. Mostly go within ion electron method, so that will be very helpful, or else do the ABCD method, okay, for the complete reaction if they have provided. And fractional coefficients, in that case it's acceptable in half reactions. Multiply the final equation to get the clear fractions. And what are the questions? What type of questions you can expect from mole concept is that stoichiometry from limiting reagents, stoichiometry from the percentage composition, and the POAC related problems. And we have this concentration interconversions kind of problems, and gas stoichiometry mixed with the limiting reagent kind of questions. And we come to the time saving shortcuts. That's very important, right? So divide the atomic mass, divide the percentage atomic mass by the smallest number and multiply to the clear fractions to get the empirical formula. And whenever the rho value, whenever they have mentioned aqueous solutions, what you can do is m is more or less equal to molarity. Okay, then ppm to molarity, you can use this formula to get the conversion. So these are the important chapter. You need to have a checklist for mole concept, because mole concept is very, very crucial. Now we completed mole concept. You can note down this question and solve and let me know the answers. Here we have 5 questions. I'm showing you one by one. You can pause the video and answer it, so that it will be complete physical chemistry revision. Taken? The next question is a multi-correct question. Which of the statement is right or incorrect type of question? Solve, and if you are having any doubt, let me know the answer. I will tell you whether that is right or not. Integer type of question, whenever you are doing integer type of question, in case of physical chemistry, solve it till the end. And again an integer type of question. Now let's go to the next chapter, solutions and thermodynamics. These two are interrelated. Again, the solution chapter, where I have these important concentration terms, which we already saw in mole concept, I'm not going to repeat. The other two important concentration term is mole fraction and normality. Okay, be careful with the normality n factor. N factor is very simple. If they have given the acidic compound or an element, not an element, acidic compound or a molecule, n factor will be number of hydrogens it can donate. Or if they have given you basic one, then number of OH minus it can donate, or if that is in redox reaction, number of electrons, as simple as that. Okay, so and the normality and the molarity conversion is very simple. In normality we are using this n factor, but in molarity we don't have. So if you just multiply m into n factor, you will get normality. Okay, then mass by weight percentage and parts per million. Parts per million question also they have asked by giving you the percentages of the element present over there in the water or some kind of solutions. And weight by mass by weight percentage, percentage weight by volume. Okay. And 1 molar becomes 1 molar when the density is equal, and 1 molar becomes 1 normal when the n factor is equal. Okay. Then Raoult's law. For a binary solution of an volatile components, you have the formula of partial pressures, and the total pressure, sum of the partial pressure will give you the total pressure, right? And these are the formulas are important. If you need this PDF, just comment PDF over here. We are working on the inorganic PDF, whoever asked for it. Soon we will release it in 1 or 2 days of both the PDFs, like physical and inorganic. And also you can start solve the problems of inorganic 250 questions, top 250 questions. And by Sunday you can start solving on physical chemistry as well. And for non-volatile solutes, the relative lowering of which will be P naught minus Ps by P naught. P naught refers for wherever the naught comes, that refers for the pure. Okay. And for the dilute solutions, the denominator we are going to neglect. So that will become the simple equation. Then Henry's law. Henry's law, they are just asking the connection which is proportional to what. That type of question also you can expect, and solubility related question in case of numericals also you can expect from Henry's law, which is very simple. Mass that is equal to Kh into P. Okay. You can in case of mole fraction, chi of gas is equal to Kh, that is Henry's constant, into partial gap, the pressure of the gas. Then colligative properties, there are only 4 colligative properties, 4 formulas, that's it. Okay, relative lowering of vapor pressure, and these colligative properties arises when the non-volatile solute blocks the surface area of the solution, right? In case of boiling point, freezing point, and osmotic pressure, these properties are depend on the number of solute particles present over there, not their nature. This is an important statement-based questions, and valid for dilute solutions with non-volatile and non-electrolyte solutes. This is the formula for our LVP, and please, this is not beta, B. Okay, delta TB is equal to KBM. Don't use molarity formula in your examination. I know that is a stressful situation, but that's why you have to practice more questions. Okay, then there are 2 type of formulas, 2 type of questions can be asked from this part in colligative property. One is straight formula. Mostly they will ask this, but sometimes what will happen, they will use this molar elevation constant to give the using that Claisius-Capron equation. Particularly in advanced, they will be asking some difficult questions. Okay, and depression point, depression freezing point also, delta TF is equal to KF. It's just while you are finding out the TF value, check out KF minus TF minus T naught or T naught minus TF. So please do careful about that. And osmotic pressure, the very simple kind of question can be asked from osmotic pressure, but the extra concept in osmotic pressure which will be asking you, they will be asking you in boards also, these concepts. Right? This is a very, very, very important concept for your boards as well. Equal osmotic pressure means pi 1 is equal to pi 2, and whenever the hypotonic solution is there, the swelling will happen. Hypertonic solution there, that will shrink. Okay, and 1.5 factor. These chapters now, solutions, chemical kinetics, electrochemistry, these chapters, if you're seeing the video now, that will be helpful for your boards as well. Okay, so spend this time 1 hour or 2 hours and finish it. Bond half factor I is equal to observed colligative property by the calculated colligative property. If the I value is greater than 1, that is dissociation. I value is less than 1, then that is association. Equal to 1 means there is no dissociation or association happens. Okay. And whenever they have given you or you found out the I value, just multiply it with the colligative property formula to get the correct answer. Then for the dissociation, alpha is equal to I minus 1 by n minus 1. For an association, alpha is equal to n into 1 minus I divided by n minus 1. Okay, so sometimes they are asking you to get the degree of dissociation value or association value as well. So for that you can use this formula. Then comes thermodynamics. So thermodynamics, these are the basic terms which we already know. Look at the state function and path function. The examples and whenever we are solving problems, this will be very, very important. Its state function is depend only on the initial and final states. We solve this thermodynamic problem. There is one big question which is purely based on this state function and path function, right? And path function means it depends on the path it taken. Heat, work done, and everything. And work in thermodynamics, this important formula W is equal to integration of P external dV or just a PV minus PV whenever it comes. And free expansion, P external is equal to 0 and work done will also be equal to 0 for irreversible process. Expansion means W work done becomes negative and compression means work done becomes positive. And reversible isothermal process for an ideal gas, W is equal to minus nRT ln by V2 by V1. Okay, this is in terms of ln. In terms of ln, you just need to multiply it with 2.303. Okay, and for adiabatic condition, we have this coefficient Cp by Cv, and these are the important relations over there. Please solve these type of questions. Don't think like I know the formula, okay, I'll do it in the exam. Please don't do that, guys. Please don't do that. And first law of thermodynamics, delta E is equal to Q plus W, and the energy of universe is conserved, which means delta E that is equal to 0. And enthalpy formula, that is also important. H is equal to E plus PV at constant pressure. Again, delta H is equal to delta E plus delta P delta V. For a chemical reaction at constant temperature, we can use instead P delta V, we are using delta N M RT. Nm means, you know, right? Moles of gaseous product minus moles of gaseous reactant. Delta Ng, we use it for equilibrium, the same thing. And heat capacity relation, this one is really important, the first one. Actually, all are important. The first one is super important. And for monoatomic gases, Cv is equal to 3 by 2 R, Cp is equal to 5 by 2 R. You can just take a screenshot of these equations, or else you can download the formula sheet from our website. Then this is an convention, sign convention for thermodynamic processes. Just take a screenshot of it. Thermodynamics and Hess law. So here we have the enthalpy change when in 1 mole of a compound formed from an element in standard state. Standard state now at 25 degrees Celsius and 1 atm. Delta HF, formation, that is equal to 0, and delta H of a reaction, that's product minus reactants. Bond enthalpy, that is sum of bond energies of bond broken minus sum of bond energies of bond formed. Okay, and Hess law, which is where the enthalpy change is independent of the, not only the Hess law, enthalpy change is independent of the path, it is a state function, right? And second law of thermodynamics, where comes the entropy. Entropy is randomness or disorderness, right? It is an extensive property, and the state function. Also, please make sure that you are studying all those intensive property and extensive properties. Intensive property, independent. Just remember like that. Okay, extensive means dependent. And mathematical derivation is that S is equal to Q by T. Right, this is an reversible isothermal formula for ideal gas. It's very similar to the previous one. Slight differences are there. And reversible adiabatic, isobaric condition, isochoric conditions. The formulas looks very similar, but it's very important too. Delta S of fusion, if you want to find, then delta HF by TF, temperature at freezing, and delta S vaporization equal to delta HV, delta H of vaporization by delta TB. And we have standard entropy formulas and Gibbs free energy. G is equal to H minus Ts, that is the basic equation. At constant temperature and pressure, delta G is equal to delta H minus T delta S. Spontaneity of the reaction. So spontaneity of entropy, Gibbs free energy and delta H. All three are very important. I will be showing you for taking the screenshot, I will be showing the table. But remember, this delta S is different from other two. Okay, just opposite. For the spontaneous process, delta G is negative, but delta S, that is positive. Okay, same applies for non-spontaneous also. This becomes positive and that becomes negative. And delta G of products and reactants are given. Free energy change, how we can find product minus the reactant. And this formula, delta G naught is equal to minus RT ln K, or you can write it in terms of log as well. And for non-standard conditions, you can use delta G is equal to delta G naught plus the RT ln Q. Q will become K when at equilibrium. The reaction at equilibrium, Q will become equal to the equilibrium constant. Okay, and that case equilibrium means what? Delta G, that will become 0. A table for delta H, delta S and delta G, and here behavior is given. Please do take a screenshot if you want. And moving on to the next one. Yeah, as I told you, solutions and thermodynamics are intermixed chapter where you can expect the questions like a Nernst equation involves the concentration and the activity coefficients in ideal gas, non-ideal gas, ideal solutions, right? So, and with solution chapter and chemical equilibrium, equilibrium constant expressions, that type of question can be asked. Because this thermodynamics chapter is super important, that can be mixed up with any other chapter like kinetics, electrochemistry or equilibrium, ionic and chemical equilibrium. Okay, and in case of solution chapter, these are the common mistakes you would do. Molarity changes with temperature, and molarity, mole fraction, mass percentages are the temperature independent. These are some statement based questions. And normality is the context dependent, like same substance, different N in the different reactions. Okay. And Raoult's law, talking about Raoult's law, we have this negative deviation from Raoult's law, positive deviation. Check out that examples of which will show the negative deviation, which will show the positive deviation. When that will show, negative deviation means AB interaction is stronger than the AA-BB interaction, and where the P total is less than the P ideal, right? And examples like chloroform and acetone, where that will have higher boiling point and maximum boiling azeotrope, that is. Azeotrope means what? Constant boiling mixtures, right? And look at this, minimum boiling and maximum boiling. Minimum boiling means positive deviation, maximum boiling means negative deviation. So these are some limitations of colligative property. It is valid only for dilute solutions and assumes the ideal behavior, no interactions will happen over there. Okay, and association, dissociation affects all the colligative properties, and Henry's law exceptions are not valid for the gases reacting with the solvent. and the temperature dependent one is in Henry's law equation. The solubility usually decreases with the temperature. These are some misconceptions of thermodynamics. For solids and liquids, delta H is approximately equal to the delta E value, almost enthalpy that becomes internal energy, where that I will have negligible P delta V value. Okay, for gases, delta H is equal to Pnm RT. In case of isothermal processes, delta E is equal to only for delta E, which is equal to 0, only for ideal gas in isothermal process, and for real gases the internal energy depend on volume also, because there is an intermolecular forces happens. And for adiabatic or isothermal processes, the temperature changes which will affect the PV, that becomes constant, which is PV is not constant, PV to the buffer coefficient, that will become constant. So whenever they are asking questions about the feasibility and spontaneity, delta G is less than 0 means that is thermodynamically favorable. It not necessarily mean that it is fast. Okay. For example, diamond to graphite process, that will have delta G value less than 0, but it is kinetically hindered process, right? And third law of exceptions, the residual entropy, like carbon monoxide, nitrogen oxide, nitrous oxide, that will have the entropy value greater than 0 at 0 Kelvin. Okay, and gases and amorphous solids violate this third law, where S is equal to 0 at 0 Kelvin. And bond enthalpy limitations, bond enthalpies are average values. CH bond in CH4, it doesn't mean that CH bond in C2H6. So, which will have the separate bond enthalpy values. So, what type of questions can be asked? These are the questions from solution chapter, intermixed with thermodynamics as well. You can just take a snip of it or pause the video and solve. This is question number 3 and 4. 4 is combined of both. Then we are moving on to kinetics. In kinetics, we have this the first very important equation. The rate is equal to minus of 1 by n1 into dA by dt. That will be equal to minus of 1 by n2 dB by dt for the decreasing amount of the reactant. So this is for the reaction A plus B forms C plus D. Okay, so that type of reaction. And order and stoichiometry. Order is an experimentally determined term, and the stoichiometry coefficients do not dictate their order. If only in the condition in the elementary reaction only it can show. And integrated rate laws, first 0 order. The most asked part is 0 order and the first order. Okay, AT, which is equal to A naught minus KT. In case of half-life, half-life means what? When the concentration becomes 50%, right? Concentration of the reactant. So T half is equal to A naught by 2K. So half-life depends on initial concentration in case of 0 order reaction. Then first order reaction, where K is equal to 2.303 by T log A minus A by A minus X. This is a very important formula whenever they are asking the age type of question. Okay, and sometimes the question can be asked in this type, like T half, this much T half is used. Just you can calculate it by find out how many T half that is. And nth order in general, through this you can find out any order type of questions. And Arrhenius equation, super important, K is equal to A e power minus A by RT. Our logarithmic form is ln K is equal to ln A minus EA by RT. If they have given the two temperature, then ln K2 by K1 is equal to EA by R into 1 by T1 minus 1 by T2. And temperature coefficient, this formula mu is equal to K into T plus 10, because mostly the 10 temperature change will be given over there by KT. And the collision theory. Whenever we are talking about the collision theory, please make a note of for the catalyst also, what are the catalysts and why that is reacting so, and what will happen if you are adding catalyst or removing catalyst, what is the duty of promoters, those type of questions. The collision theory, which is related with catalyst purpose. For the effective collision requires, first of all, the energy must be greater than the threshold energy and the proper orientation should be there. Okay. What is threshold energy? Threshold energy equal to the energy barrier that have to cross, right? So the minimum energy required to proceed the reaction to cross the barrier, that is threshold energy. How we can find it out? Threshold energy equal to activation energy plus average kinetic energy of the reactant. The energy diagram, if that is given, here I just want to tell you a few things. Let's say I'm starting the reaction from here, okay? So I'm starting the reaction from here, the reactant is here. So tell me, reactant is stable in the product or product is stable in the reactant? Of course, reactant becomes stable because that is having less energy. Let's say this is reaction coordinate, this is energy, okay? And also these are the points where the threshold energy barrier formed, and these are the points where the intermediates are formed. Sometimes the questions can be asked from that part as well. And also remember, intermediates are more stable one than the that will live for longer period of time than the transition state. Okay. And pseudo order reaction, when one reactant is large excess, for example ester hydrolysis, the effective order decreases. Here I have ester and water, but the true order what we found is 2, but technically it becomes 1. That's why we're calling it as pseudo first. Okay, so these are some integrated first order kinetics rate expression along with the derivation I just provided you. But the important formulas are ln A by AX and this one. For the half-life, T half is equal to 0.693 by K. Don't ever try to forget this 2.303 when switching from ln to log. This one we already saw for log K2 by K1, that is equal to EA by 2.303 R into T2 minus T1 by T1 T2. These are the common traps of chemical kinetics. The order that is an experimental can be 0, can be fractional or negative, but the molecularity that is theoretical, it will be always a positive integer defined only for the elementary steps. And for the complex mechanisms, the overall order that is not equal to sum of molecularities. These are some statements I have given you for statement-based questions or common misconceptions. You can note it down or just go through it once so that you will not do the mistake again. Then comes our very important chapter, electrochemistry. First, let's talk about the conductance relations. Specific conductivity kappa is equal to 1 by rho, which also can be written as L by RA. So A stands for the cell constant over here, and this conductivity decreases with dilution. Okay, and molar conductivity that increases with dilution because the ions can move freely. It reduces the inter-ionic interactions. Equivalent conductivity, the formula is given, and Cold-Rush law, very important relation. It includes the application of Cold-Rush law. It used to calculate the delta naught of lambda naught of weak electrolytes, conductivity of weak electrolytes. Please note down this type of problem. Please do attempt this type of problems also for your mock test. And small heads up, we have released the mock test papers as well. It includes 12 mock test papers, starting from mixing of the difficulty level till the most difficult, who were aiming for the advanced. That type of questions were also included there. So please do check out. For coming back to the concept, degree of dissociation, alpha is equal to m by m naught. And then electrode potentials, absolute value cannot be measured, so we always take it with the standard hydrogen electrode. So more positive means stronger oxidizing agent, more negative means stronger reducing agent from the EMF table. Okay, so delta E naught cell is equal to E naught cathode minus E naught anode. That formula we know, right? And according to the Nernst equation, we have this for a complete cell. E cell is equal to E naught cell minus 0.0591 by N log Q. Q refers for products by reactants. Okay, at equilibrium, E cell is equal to 0 and E naught cell, we shall have this formula. And how it is related with the thermodynamic equation is that delta G is equal to minus NFE, right? Delta S is equal to NF rho E by rho T, dou T by dou T at constant pressure. Delta H is equal to delta G plus T delta S. So where we can substitute the delta G values. And most important laws, that is Faraday's law. According to the first law, W is equal to the weight of the deposited amount, that is equal to ZQ. Q can be written as IT, I for current, T for time, and Z is equivalent weight by F. F is 96,500. From the second law, W1 by W2 is equal to E1 by E2, and delta G3, if they have given this non-additive property, we can't add the half cell potentials directly. So for that kind of problems, we can use this. Batteries and fuel cells, from this part you can expect the statement based question, or else they will be asking you from the reactions. Okay, which is consumed where, which is left over what, and whether this can be used as that. That type of statement based question can be asked, and also efficiency based questions. Okay, so whatever I have written over here, those are very, very important. Please do check that out. Our next chapter, that is atomic structure. Here the most important part is quantum numbers, radial nodes, and then questions related to that. More model of extensions, those equations. I just have listed over here principal quantum number, that the statement based question. So what principal quantum number refers, and azimuthal quantum number or magnetic quantum number, and what are the possibilities over there. That type of questions you can expect there. Okay, then orbital energy order depends on n plus L rule, Bolberry's rule, but exceptions rise when the energy levels are nearly degenerate, like chromium, copper, those exceptions. Angular node, radial nodes, and total nodes type of question. And we have this Bohr model extensions like En is equal to minus 13.6 Z square by N square for hydrogen-like species, and the velocity, radius kind related equations, how it is proportional to that. Right, the transition energy for the hydrogen-like species is scales as Z square, and the wavelength relation is often tested with their series of overlaps. Okay, that type of question can be asked. And another question is de Broglie equation, Heisenberg uncertainty principle, Those equations are very much important. And other than that, this spectral analysis, hydrogen spectrum. Okay, the maximum spectral lines from level n, that is n into n minus 1 divided by 2, and the lines in the particular series, that is, let's say n2 to n1, n5 to n4, n5 to n3. So that kind of question, n2 minus n1 will give you the lines. And Rydberg's formula manipulation, that you know. And another important thing over here in the spectrum analysis is whether they have given the sample or one atom. So that type of question, do the how to differ those spectral lines. Okay, one atom means there is only one transition, right? One atom is jumping from 4 to third state, 4 to second state, like that. But if they have given sample of atom, sample of hydrogen atom, there will be more atoms. So the jumping will be different, right? Then we have Bohr's radius and energy relationship, MVR is equal to NH by 2 pi, and other equations are given over here. Then what things you need to remember in atomic structure is that don't forget about this exceptional cases of electronic configurations. Palladium, copper, chromium, and lanthanum, cerium, gadolinium. And this graph type of questions, we already solved this, right? Wherever the cut happens, that is equal to one node. So node position does not imply zero probability everywhere on the surface. More nodes, it doesn't mean equal to always the higher energy. Okay. And that's it about atomic structure. Very simple chapter, but very important chapter. Then chemical bonding. In chemical bonding, mostly the questions will be asked from hybridization and structure and MOT. Okay. So DCPR, what are the structures we have that you just need to work upon? And then we have this repulsions, lone pair repulsion, lone pair, and bond pair. And isoelectronic species with the same hybridization but different central atoms. The bond angle is directly proportional to electronegativity of the atom. And this point, NH3 and phosphine, if you compare, the bond angle decreases down the group despite the same hybridization it may follow. Okay. And molecular orbital theory, what is below 14 and after 14? And here the questions can be expected from bond order, bond length, which are inversely proportional to each other, and how many electrons in the anti-bonding level, how many electrons in the bonding level. That type of question can also be asked. Then dipole moment. Which of the following is having more dipole moment? That type of questions. Not exactly the dipole moment value they won't be asking. They might be asking which will have more, which will have less, which will be zero. That type of question you can expect. Then hydrogen bonding, which is related with our solubility, volatility, boiling point, melting point. So if there is an intermolecular hydrogen bonding, it increases these boiling point, viscosity, melting point, and decreases the volatility. And intramolecular hydrogen bonding, it decreases the melting point. Remember that, because of the shape changes. Because the melting point is always related with the how the lattice structure it is arranged, how the arrangement happens. Boiling point is related with the how much the weight that is, or how it is having more bonds. That related questions can be asked. And the strength order can also be tested. Ortho-substituted phenols show intramolecular hydrogen bonding even in diluted solutions as well. Then ionic character. So think about the stability also in case of chemical bonding. They will give you some resonance structures and ask you to find which is more stable. That type of questions can also be expected. Covalent factor is directly proportional to polarization, which is directly proportional to charge and inversely proportional to the size of the cation into size of the anion. Always remember, this anion would be bigger in size than the cation. These are the special cases in chemical bonding. XCF6 has a distorted octahedral geometry due to the lone pair of stereochemical activity, and IF7 has pentagonal pyramidal shape, and CLF3 has a T shape, and BRF5 has a square pyramidal shape. So these are some special cases. It's better to remember it. Then we are moving on to the chemical equilibrium. Chemical equilibrium, that is a very simple and important chapter, I would say, because this give you free marks. There are very few equations or formulas in this chapter. Kp is equal to Kc into Rt over delta Ng. So that can be asked, that relation. And here you should not include any liquids or solids because the formula itself delta Ng. Okay, gases for gases only. Okay, so you should not include solids or liquids. And the inverse reverse reaction K, how it changes, K dash is equal to 1 by K for a multiplied stoichiometry. If that is doubles, what will happen? If it is halved, what will happen? So keep in mind this relation. Okay, so these two formulas are also important. And reaction quotient, I already told you Q becomes equal to K when that is in equilibrium state, and K becomes higher means that proceeds to forward reaction. If the K value is smaller than Q, then it is backward reaction. There can be some questions which is related with these two, finding out Q value and relating it with K. Okay, so to shift the forward or backward reactions. Then degree of dissociation, the simple formula d minus d by t into dn minus 1, that's given. And more importantly, chemical equilibrium means Lee-Sartler principle, right? Adding inert gases won't affect. Adding inert gases at constant pressure shifts towards the side with the more molecules where the volume increases. That's why there is a shift happens, not because of the inert gas. And adding inert gases at constant pressure means there will be more molecules happens. That's why the volume getting increases. Okay. Then temperature effect for an exothermic reaction, K decreases with increase in temperature, and for an endothermic, K increases with temperature. The catalyst changes the rate but not the K value, rate constant value or the equilibrium constant value. And how delta Ng value changes, that is also listed over here. And the relationship between Kp and Kc, I gave you the formula already. These are the derivations of the formula. And what is the R value you have to use? It's depend on the question they are asking, depend on the options you have. Okay, so it's better to know at least 3 R values, like 8.314 for joule per Kelvin per mole, or another one is 0.0821 liter ATM per mole per Kelvin, and if that is given in calories, then 2. Okay, 2 you can use. Degree of dissociation with vapor density. This is the derivation and the formula I have given with that. And vapor density, which is equal to molecular weight divided by 2. Wavelength ratios, you can use this shortcut for atomic structure, and it's better to remember the common geometries what they are following, at least to know what kind of repulsions they happen, so that you will predict which is having which geometry. Then these are the questions from atomic structure, chemical bonding. You can take a screenshot of it and solve it. Then finally we come to ionic equilibrium. In ionic equilibrium there are lots of formulas, but repeatedly they are asking few. I have uploaded the repeated questions, top questions to solve on ionic equilibrium. Please do check out. That's a very interesting chapter. First of all, acid-base theories. These we know. What is Arrhenius theory? H plus generator in water, OH minus generator in water for base. And Lowry-Bronsted theory, acid is in proton donor, base is in proton acceptor. And you have to know about this Lewis acid and bases. Lewis acids are the acceptors of the lone pair and the bases are the donors of the lone pairs. Right. And amphoteric species can act as both acid and bases, like a H2O, bisulfate, like that. And amphiprotic means specifically for Bronsted acids and bases. Then degree of dissociation and Oswald's dilution law. Degree of dissociation alpha, which can be related with many chapters of physical chemistry chapter. Okay, so for strong electrolyte, that is almost equal to 1. And for weak electrolytes, it's less than 1, typically less than 10%. So always remember, if that is in strong acid or strong base, that mostly act as in strong electrolyte, even that is in dilute solution. Okay, some students will misunderstood this dilution with the weak. Okay, don't do that. Strong means always the strong. It's like an identity. And weak electrolytes that will have very less than 1, typically less than 10%. What are the factors will affect the alpha value? Nature of the electrolyte. Stronger electrolyte means higher the alpha value. And nature of the solvent, higher dielectric constant means higher alpha value. And dilution, increasing dilution, which will increase the alpha value. And the temperature, increasing temperature will increase the alpha value. Okay. And connecting Oswald's dilution law with the alpha, we have this very simple equation from the table. Ka is equal to C alpha square by 1 minus alpha. So alpha increases with the dilution. Alpha is inversely proportional to root C concentration. Okay. They won't be asking directly about this formula, but they will be giving you the values of concentration. This much moles are there. That type of question you can expect. And concentration increases means alpha decreases in case of dilution. Then pH. The first part is related to alpha. The second part is related to pH. So pH we know minus logarithm of H plus. So at least know the pH value of, log value of 2, log 3 and other values you know. Log 10 means 10 means 1. Log 100 means 2 zeros I have, so 2. Okay, so at least know these values, and if I'm having 10 to the power 3, then it's got come to before the values. Okay, then POH is equal to the same thing. Wherever the P term comes, pKa, pH, POH, pKb, pKw, then always it relates with the minus of that value. Okay. Then pH plus POH, which is equal to 14. Sometimes in questions they will give you the base and you will be calculating POH value, but the question they will be asking for pH. Okay, so please make sure that you are reading the question very carefully. KW value, that is equal to 10 to the power minus 14, which is in temperature dependent, and at 80 degrees Celsius it becomes 10 to the power minus 13. It always constant at a given temperature. These are some statements. And this scale, pH scale, you know, from 0 to 7, 0 to 6.9, that is acidic, 7 to 14, 7.1 to 14, that becomes basic, and 7 means neutral. And the pH scale changes with the temperature. Okay. So first of all, strong acid. Strong acid means it will have the concentration of acid concentration will be greater than 10 to the power minus 6 molar. Okay, that is case 1. So if that case, then we can neglect the H plus concentration from the water. And in case 2, the acid concentration is less than 10 to the power minus 6. Then that concentration is very, very small, right? So we cannot neglect the H plus concentration from the water. So then we have to add both the concentration, H plus from the acid, H plus from the water, both. So here you know for 10 to the power minus 8 molar HCl, we just have calculated how it is getting dissociated. Okay. Then strong bases. So strong bases, which is very similar to strong acid only. Calculate the OH minus first and then use the KW value 14 to find out the pH value. Then you can find out H plus. Then weak acid solution, we can use this C alpha square divided by 1 minus alpha, that formula, to find out the Ka value or concentration or alpha value. Anything can be asked as a question. At very low concentration, C approaches 0, weak acid will behave as a strong acid. Okay, this statement is very important. Then weak base solution. Weak base, OH minus concentration, which is equal to root of Kb C POH is equal to 1 by 2 pKb minus log C, or pH is equal to 14 minus pH, POH. Okay. Then in case of polyprotic weak acids, H2A, that type of solution like H3PO3, PO4 or H2SO4, that type of solution, K1 and Ka2 will be there. So in that case, what we have to do, that is polyprotic weak acid. The examples were not weak acid, but I'm just telling you what is polyprotic. Okay, in those cases you can use the formula like this. Then mixture of pH calculations, like mixing of strong acid. In that case, you can use the total molarity will be the sum of normality into volume. Okay, then H plus would be N1V1 plus N2V2 by V1 plus V2. If that is a strong base, again OH minus will be the same answer. Then mixing of strong acid plus strong base, both are strong now, but acid and bases, then neutralization occurs. That is the most important mistake you would make, because after neutralization, if that is equal, then that don't be acidic or basic, right? And it will produce salt and water. Whenever we are calculating this kind of neutralization reaction, how much H plus concentration left, how much OH ion left, so that we have to calculate to find out the pH. Okay, please remember that. Then mixing of two weak acids, again the formula is given for Ka1 C1 plus Ka2 C2 plus Kw of whole to square root. Another one is mixing of weak acid plus strong acid. Strong acid suppresses the weak acid dissociation, so common ion effect will happen, so the formula will change like this. And then we come to salt hydrolysis. Salt plus water gives acid plus base, right? That is an equilibrium reaction, that is a reversible reaction. First, you have to know about hydrolysis constant. The anionic hydrolysis, that is KH is equal to Kw by Ka. Cationic hydrolysis means Kw by Kb. Then degree of hydrolysis, that is a fraction of salt that undergoes hydrolysis. How much of a salt is undergoing hydrolysis. H is equal to square root of Kh by C. Here we have few types. Type 1 would be salt of strong acid plus strong base. Okay, so in that case pH will become 7. And the second type is salt of weak acid plus strong base, like sodium acetate with sodium carbonate, like that. Then you have to use pH is equal to 7 plus half pKa plus log C. Okay. Then type 3 is salt of strong acid plus weak base. 7 minus half pKb plus log C, that formula you can use. Type 4, that is salt of weak acid plus weak base, where I have pH is equal to 7 plus half pKa minus pKb. So note down all those formulas or comment formula sheet for this ionic equilibrium, because this is the chapter where you have lots and lots of formulas. Then polyvalent ion hydrolysis, like it occurs in the stepwise. Okay, so which step dominates, that you have to know. That type of question can also be asked. Then amphiprotic ion hydrolysis, which can donate and accept the electrons. Dual behavior happens over there. For that, pH is equal to half pK1 plus pKa2. Then finally, buffer solution. Buffer solution means what? The solution that can resist the pH upon the small addition of aceton or bases. It can be of two types, basic buffer and acidic buffer. Basic buffer will have more than 7 pH and acidic buffer will have less than 7 pH. And the examples are given over here. Here comes the Henderson-Hasselbalch equation. For acidic buffer, pH is equal to pKa log A minus HA. That means salt by acid concentration. Okay, for basic buffer, okay, B minus BH plus, base by salt concentration. That changes over here, please note down. Then buffer range. I think in one of those January paper they have asked this type of question, buffer range. pH range that can be found out by pKa plus or minus 1 and pOH range, that is pKb plus or minus 1 for acidic and basic buffer. Then buffer capacity, the amount of acids or base required to change the pH by unit 1 unit. So dN by D, difference in pH. Okay, delta N by moles of acid by base added divided by what is the pH change happen over there. Okay. Then effect of dilution, pH remains essentially constant. The ratio will remain unchanged, both decreases proportionally. And acid-base titrations. Strong acid versus strong base means the equivalent point will be 7 and the sharp pH change happens 7 to 10 and the indicators are methyl orange, methyl red, phenolphthalein, all will work. Shape of the curve would be S curve. You remember? And weak acid versus strong base means equivalence point is greater than 7 because remember strong base is there. Remember strong base is there. So overall the solution will be strong basic side, right? So pH will be greater than 7. And for the buffer region, before equivalence point it happens and indicators, that is phenolphthalein, we can't use methyl orange, that remember. Then strong acid versus weak base, the equivalence point is less than 7 and the pH at the equivalent point that can be found out using the formula. And the indicator is methyl orange, we can't use phenolphthalein over here. And weak acid versus weak base, there is no sharp pH change at the equivalence point, no suitable indicator, not suitable for accurate titrations. Then talking about the indicators, we are referring HIN. Acid base indicators are weak organic acids or bases. They will show the different color in acidic and basic conditions. Okay. Universal indicator means that is a mixture of several indicators, shows different colors from the pH 4 to 11. We are usually using phenolphthalein, methyl orange, methyl red and bromothymol blue and the ranges are given over here. Then solubility, the maximum amount of solute that dissolves in given solvent, that is solubility. Here two types of questions can be asked. Either they deal with KSP or they deal with S, solubility. Okay, so find out the find out the KSP. If solubility is equal to S, then KSP becomes this. Okay, so for AgCl, Ag plus and Cl minus, both are monovalent, right? So the KSP becomes S square. And here you see 2:1 ratio, then 4S cube and 3:2 ratio 108 S to the power 5. By doing more problems, these numbers you will automatically it goes to your prime. Then common ion effect, very important concept. The solubility decreases in the presence of common ion. Okay, and also the common ion effect related with the dissociation also. Why the solubility decreases? Because it will not get dissolved in the presence of the common ion we are adding, right? So AgCl in NaCl solution, we can calculate the X value of solubility, KSP by C. And when the precipitation happens, when the precipitation will not happen. The product of the actual ion concentrations, that is what ionic product is. If the ionic product is greater than KSP, the precipitation will happen, that is supersaturated solution. If the ionic product is equal to KSP, then that is in equilibrium, saturated solution will form. If the ionic product is less than KSP, then there is no precipitation happens. Okay. So why the precipitation is very important? That will be useful for separation of the ions. So you can work on for ionic equilibrium part. Top 5 questions I just have listed over here. And let's solve more and more problems. The mock test series are open now. You can start solving the problems which I have uploaded. And let me know what else you want from us to get more marks. Okay, let's see in the next video.